Expanding universe. Why does everyone think the universe is expanding? Is the universe expanding? Seems like a simple question with a simple answer. If you ask any astronomer this question, they would quickly say, yes, of course it is. It has been a common belief for a very long time. The story behind how and why astronomers believe this is quite complex and very interesting. This article was created to look into the story and to explain it. It is also intended to ask the question, did the astronomers get it right? Dark matter is believed to be matter that we cannot see. The universe is a dark place, and our instruments to observe it are limited. There is a lot of things in the universe that we cannot see or detect with our instruments. The story behind dark matter and how it works is a very interesting story. It started with Vera Rubin. She was an astronomer and liked to study galaxies. In the late 1970s, she observed that matter in the galaxies seemed to be moving at the same speed. The matter near the center of the galaxies appeared to be moving at the same speed as the matter on the edge. She also observed that the speed at which the matter was moving at the edge of the galaxies seemed to be too fast. According to her interpretation of Newton's gravitational laws, the matter should be flying out into outer space. Based on her understanding of how galaxies should behave, this did not make sense. She assumed that galaxies behave like solar systems. In a solar system, the planets rotate around a star. When planets orbit their stars, the orbit slows down according to the distance they are from the star. If a planet is moving too fast, then the planet should be moving away from its star. Assuming that galaxies behave like solar systems, then they should be doing the same thing. The reality is there is a big difference between solar systems and galaxies. Galaxies are not just planets revolving around stars. They are full with matter in all shapes and sizes. This matter is distributed throughout the galaxies and it interacts with itself in ways different than in solar systems. According to Newton, gravitational force decreases exponentially as distance increases. This means that the gravitational force of the center of the galaxy on the outer galaxy is significantly less than that of a star on a planet. It does not make sense to expect that all matter in a galaxy is simply revolving around its center like a solar system. There must be something else going on. In a solar system, there are just a few planets orbiting a star. A galaxy is filled with objects that are bound together by gravitational force. This bonding force could also explain why all the matter in a galaxy is moving together and at the same speed, and why the matter on the edge of a galaxy is not being ejected out of the galaxy. Dark matter was created to explain something that seemed not to make sense. Galaxies are complex, and it makes sense that our observations are confusing. It should be obvious that galaxies do not behave like solar systems. Instead of looking for dark matter, maybe astronomers should be working on a new model of how gravity affects galaxies. What is the cosmological constant? In 1917, Albert Einstein released a paper called Cosmological Considerations in the General Theory of Relativity. It was his intention to use this to explain how his theory of relativity can be used to explain the behavior of stars and galaxies. He encountered a problem when doing his calculations. According to the laws of gravity, the universe should be collapsing in on itself. Einstein believed at the time that the universe was static, and he needed to adjust his calculations to reflect this. In order to address this issue, he introduced a variable into his equation to get it to work. He called this variable the cosmological constant. This variable was made to be a constant in order to explain a universe that was static. In 1992, Alexander Friedmann introduced the theory of an expanding universe that contained matter that was moving. He modified Einstein's equation by giving the cosmological constant a value. Alexander Friedmann demonstrated that Einstein's equation could be used to explain a universe that was expanding, static, or contracting by giving the cosmological constant a positive, zero, or negative value. A few years later, Edwin Hubble announced his findings that were based on Carl Wilhelm Wirtz's observations. Hubble's interpretations of his observations were considered as proof that the universe was expanding. In 1927, Belgian astronomer Georges Lederer also independently reached the same conclusion. In 1931, Einstein abandoned his concept of a static universe as a result of Hubble's observations. He could not argue with the widely accepted idea that the universe was expanding and gave in to public pressure. Later in life, Einstein reportedly said that using the cosmological constant to describe a static universe was his biggest blunder. During this time in history, astronomers decided that the universe was expanding, and this has been considered a fact ever since. Astronomers refuse to consider any theory that does not agree with this, regardless of common sense or facts. In addition, all new observations are interpreted in ways that confirm the expansion of the universe theory. The reason for this is a phenomenon called confirmation bias. What is fourth dimensional observation? How does fourth dimensional observation work? Light takes time to travel to us. When we observe a galaxy that is 1,000 light years away, we are actually seeing this galaxy as it was 1,000 years ago. When we observe a galaxy 13 billion light years away, we are seeing it as it was 13 billion years ago. When we make cosmological observations, we need to take time into consideration. The factor of time can have a material effect on how we interpret our observations. It is important to understand that we are not seeing things as they are, we are seeing things as they were in the past. Fourth dimensional observation is a fundamental astronomy concept, something that every astronomer learns in school. It is amazing to think that astronomers could not accurately reflect fourth dimensional observation in one of their most important cosmological theories. What is the Doppler effect? How does the Doppler effect work? In general, the Doppler effect is when the frequency of a wave changes because the observer is moving relative to that wave. With sound waves, this can be observed on Earth when an ambulance passes by an observer. The siren sounds different as the ambulance approaches and as it drives away. In the context of this article, we refer to the Doppler effect as something that affects light waves and affects the way in which we observe our universe. Scientists use the Doppler effect to determine how objects in the universe are moving relative to Earth. The theory is that a galaxy that is moving away from us should appear more red than a galaxy that is not, due to the Doppler effect. The faster a galaxy is moving away from us, the greater the shift towards the red should be. This process of light being shifted towards the red spectrum will be referred to as redshifting. There is a problem with using the Doppler effect to determine the movement of galaxies relative to us. According to fourth dimensional observation, we are observing the galaxies as they looked in the past. This means we cannot tell how the galaxies are currently moving relative to us. We can only see how the galaxies were moving relative to us in the past. It is impossible for us to know for sure what a galaxy billions of light years away is currently doing. We can, however, assume that all galaxies go through a similar life cycle. This would mean that the galaxies far away from us currently look similar to and are behaving like the galaxies near us. What is Hubble's law? Why did Hubble think that the universe is expanding? In 1929, Edwin Hubble announced his findings that he noticed a spectral shift towards the red while observing galaxies, and that the farther away a galaxy was, the greater the red shifting was. This shifting was accredited to the Doppler effect, which would mean that the galaxies are moving away from us. In 1998, two independent projects used supernovas to more accurately observe the redshifting observed by Hubble. The new data demonstrated that the redshifting was even greater than expected. According to astronomers, this would mean that the movement of the galaxies away from us is accelerating as the distance from us increases. The redshifting observed by Hubble has also been accredited to cosmological shifting. This would mean that the universe is expanding. Some astronomers use Hubble's observations as evidence for cosmological expansion. The problem with this interpretation of Hubble's observations is that it does not accurately take into account fourth dimensional observation. When the concept of time is correctly reflected in the interpretation of Hubble's observations, it indicates a different version of what's happening. This version disagrees with what astronomers currently believe. Interpreting Hubble's observations. What did Hubble observe? How should we interpret Hubble's observations? Most, if not all, astronomers currently believe that the universe is expanding. This is because of the way they are interpreting Hubble's observations. They accept the redshifting observed as proof that the universe is expanding. There is, however, another interpretation. If we use fourth dimensional observation, we could say that the farther away a galaxy is, the farther back in time our observations are. It is a fact that most galaxies that are further away from us have more redshifting. This means that the farther back in time we observe, the greater the redshifting was. This interpretation demonstrates that a long time ago, galaxies were moving away from us. As time has gone by, this process has slowed down and is currently not even happening. When we observe galaxies relatively close to us in distance and time, this process has seemed to have stopped. It is not unreasonable to assume that the galaxies billions of light years away from us are currently behaving like the galaxies near us. This would mean that the universe is currently not expanding and that the current theory of cosmological expansion is not accurate. The answer to the question, does dark energy exist, is not that simple. When astronomers decided that the universe was expanding, the first question in everyone's mind was, why and how? No one had an answer to these questions. In order to give their expanding universe theory credibility, they needed an answer fast. They came up with dark energy. They suggested that there must be some unknown force of gravity in the universe that makes the universe behave how they want to believe it's behaving. Astronomers want the universe to be expanding so bad that they will not consider any information that does not support this theory. Anyone who even suggests that the evidence supporting this theory could be flawed will be ridiculed and ignored. As far as astronomers are concerned, the universe is expanding and dark energy is driving this expansion. It is amazing that so many very smart people are so willing to believe in an idea that was created solely to explain a theory that did not seem to make sense. Is it really so crazy to think that maybe there is another explanation? Is it unreasonable to propose that a theory that astronomers cannot fully explain may be flawed? There have been a lot of scientists trying to figure out what dark energy is. A lot of resources have been dedicated to trying to figure out what dark energy is. At this point in time, astronomers just don't know. Maybe instead of searching for dark energy, astronomers should be looking at the way they are interpreting their observations. Interstellar clouds. What are interstellar clouds? How do they affect Hubble's observations? An interstellar cloud is made up of gas, plasma, and dust. They exist in the interstellar medium. This is an area in space between star systems and galaxies. The interstellar clouds we have observed have been large. They were in the right place under the perfect conditions for our instruments to observe them. There are probably a lot of other interstellar clouds that we cannot see. We cannot see 85% of the matter in our universe, and many astronomers believe that some of this matter exists in the form of interstellar clouds. This would be an example of matter in our universe that we cannot see. They are composed of various things, but hydrogen and nitrogen are common gases found in interstellar clouds. The composition of interstellar clouds is relevant because when light passes through them, they can cause redshifting. When light travels between star systems and galaxies, it could encounter interstellar clouds. These clouds are composed of materials like hydrogen and nitrogen. These two elements are known to cause redshifting due to a process known as Rayleigh scattering. Galaxies. How did galaxies form? How have galaxies changed over time? There are a few theories about how galaxies have formed. Most theories agree that galaxies started out as clouds of dust and gas. Due to reasons that are debatable, these clouds collapsed, condensed, and the galaxy's first stars were born. Galaxies are believed to have a common life cycle. Stars usually end their life cycle in one of two ways. Smaller stars create a planetary nebula when they run out of fuel, and larger stars create a supernova explosion. Both of these events create clouds of dust and gas. Then, new stars form out of dust and gas, and the process repeats itself. When stars die, they usually leave behind a white dwarf, neutron star, or black hole. These objects are created out of materials that were found in the cloud that they formed from. This means that every time a star goes through its life cycle, there is less gas and dust in the galaxy. When observing galaxies in a fourth-dimensional context, the galaxies start off as clouds of dust and gas. Then, stars go through their life cycles, constantly reducing the amount of gas and dust in the galaxy. This means that the longer a galaxy has existed, the less dust and gas it has. The life cycle of galaxies and stars is relevant when observing galaxies because the galaxies look different at different times in their life cycle. When observing galaxies, it is important to take into consideration how far away it is and how long the light took to reach the observer. With this information, it is possible to determine at what point a galaxy was in its life cycle when the light left it. Rayleigh scattering. What is Rayleigh scattering? Can Rayleigh scattering be used to explain Hubble's observations? Rayleigh scattering is an optical phenomenon that occurs when light encounters particles or gas. When light passes through clouds of particles and gas, some of this light gets reflected. Red light has a lower wavelength, which means that it gets reflected less than other colors. This results in redshifting. Various gases and particles in interstellar clouds cause Rayleigh scattering, including hydrogen and nitrogen. When light travels to us from far away, it could encounter these clouds and be affected by Rayleigh scattering. The farther the distance and the longer time light travels increases the probability of being affected by Rayleigh scattering. This means that galaxies should be more red the farther away they are. This could also explain what Hubble observed. The more dust and gas that a galaxy has, the greater the effect of Rayleigh scattering should be. The early galaxies were full of dust and gas, and the redshifting from Rayleigh scattering should have been much more significant than it is today. As the amount of gas and dust reduces over time, the effect of Rayleigh scattering should also be reduced. This could also explain what Hubble observed. Rayleigh scattering does not just happen in outer space. It can also be observed here on Earth. It is what causes sunsets to be red. When the sun is setting, it travels through more of the atmosphere than usual. As a result, it encounters more dust and gas. This causes the effect of Rayleigh scattering to be greater. Is the universe currently expanding? Was the universe expanding in the past? If the Doppler effect is responsible for the redshifting observed by Hubble, this would not mean that the universe is currently expanding. When taking fourth-dimensional observation into account, it would mean that the universe was expanding in the past, and this process has been slowing down with the passage of time. Rayleigh scattering is real and causes redshifting. We can observe it on Earth and in outer space. It does affect our observations. It is unreasonable to assume that light can be traveling 13 billion years through space and not encounter anything that causes Rayleigh scattering. The universe is not empty and contains much more matter than we expected. Some of this matter is in the form of gas and dust in interstellar clouds. These clouds cause Rayleigh scattering. The farther light has to travel to reach us, the greater the chance is that it will encounter gas and dust in interstellar clouds that cause Rayleigh scattering. A long time ago, the galaxies had much more gas and dust. This means that the younger galaxies should have much more redshifting due to Rayleigh scattering. As time went by and galaxies matured, they became less gassy and dusty. This reduced the effect of Rayleigh scattering and caused the redshifting to decrease. Rayleigh scattering could also explain what Hubble observed. With this interpretation, Hubble's observations would not be able to be used as proof that the universe is expanding. It would mean that the universe is currently not expanding and that it was not expanding in the past.